And that concludes our look at all the various options you have for storing state in an ASP.NET application. Everything ranging from application to per client state using session state or cookies or query strings or profile. We also looked briefly at view state for keeping state across postbacks, as well as the item collection for retaining state across elements within a single request. The newer cross-page posting feature to propagate state from one page to another by doing a direct post. And then finally, the pair of controls that you might find useful for managing state on a single page, but actually changing the look and appearance to a user based on interaction with the site. So we'll start our discussion of state in ASP.NET with a look at application state. And I want to give you a warning that in most modern ASP.NET applications, there really aren't many scenarios where application state is going to be the one that you want to reach for. And there are a couple of reasons for this that we'll get into. But let's start with just a brief description. So application state is available globally in the application. This is a global state repository. It's a name value collection, a hash table that is defined once in each ASP.NET application on your site. And you can use it just to insert data and then retrieve it later somewhere else in the application. The way you access it is through the application property of the application class. So there's an HTTP application class that we looked at in our pipeline talk, and that has an application property, which is in fact the state bag you can add things to and read things from. There's an application start event, which is fired when your application first begins and is launched. And you can use that to initialize state in there if you want to. It is important to remember that this is a shared state collection across all the pages in your site. So if you're ever making modifications to state inside of this state bag, you need to take care to acquire a lock prior to making modifications and then relinquishing that lock by calling unlock on the application when you are finished. And by the way, this is primarily what should send a red flag up for you, which is the fact that you have to do locking and unlocking of the data access to this collection. That's going to potentially introduce bottlenecks in your system and really reduce the scalability of your site. So if you're at all concerned about scalability of your site, anticipating a number of users that may want to access your application concurrently, which you typically do, this is something to be avoided. Okay, but for simple applications, this often is the easiest place to put state. It's almost like having a global buffer of memory that you can just have available for everyone. So it can be simple to work with, but it does incur penalties if you use it too much. Also keep in mind if you're deploying to a web farm or you have a web garden deployment, which means you have a separate process per CPU on your machine, this is not shared. So each instance of the application will have its own collection of data. And just moving forward, I do want to point out that you probably want to prefer the data cache in ASP.NET today over the application state bag. So if you're not going to be using modifiable state, which is the recommendation, then all you're going to be doing is putting in read-only state into this application state bag. And if you're putting read-only state in the state bag, you probably want to be putting it in the cache. And we'll talk more about that in a bit. But let's go ahead and show you the mechanics of interacting with the application state bag. So here's an application start event inside of our global ASAX file. And we're preparing a data set and caching it in the application state bag. So notice the syntax here is just using the overloaded indexing operator with a string to place an element in there. And then you can put whatever object you want to. It just stores a collection of objects. And then later you can extract that out and then use it in your application, drawing it directly from memory. So let's go back and take a quick tour of using the application state bag. What I have here is an example of a page that's displaying data from a data source. And I actually have a little database right here called quotes. And this just has a table called quotes inside of it, just one table and that table has some quotes from famous people along with author names. And what I do in my code behind for this page is I'm going to populate this label with a random quote from that database. So here's the code for doing that, and we're going to talk more about data binding in a future module, so we'll get into those details. But here's a quick snippet. So we're going to prepare a data table. This is an in-memory object that you can cache the results of a query in. And I'm going to go to my configuration file and pull out the connection string for that little database there. And then I'm going to prepare a SQL data adapter that's going to select the author and quote from the quotes table, passing in that connection string. And then we'll fill up the data table. So here's the data table quotes. And then I'm going to extract out a particular quote from that table by generating a random number here between 0 and the number of rows in the table. And I'm going to pull out the quote at that row index, as well as the author, and print it to my little label. So this is a good candidate for caching because this table is not going to change very much. And every time this page is hit, as you'll see here, it's going to incur a database query. And if that database were off this machine, off in another across the network somewhere, that could take an amount of time that would reduce the speed with which this page was sent back to the client. Okay, so there's our page with a daily quote on it. And let's go cache this table now inside of our application data store instead of retrieving it every time. So let's go ahead and grab this stuff right here. Actually, let's grab all this. Okay, so I'm going to grab all this. I'm going to go into my Solution Explorer and add a new application class, global.asx file, which we looked at in our HTTP pipeline discussion. And notice the application class gives us an application start event. So here's where you could do some initialization. And we're going to do that. Let me bring in a reference to the namespace for system.data. And also I'm going to be using system.data.SQL client as well as system.configuration. So those are the three namespaces I need. And we're going to prepare this data table just like we did before. We're going to pull it out of the database. And this time, once we have it filled out, we're going to grab the application class. And we're going to drop into it this quotes table. So I'm just going to put this index with quotes table and set it equal to the quotes table that we just populated. Okay, so there we go. We have a quotes table in memory that's going to be in the application class. And what I can do in my page now, and again, this is going to be called as soon as the application is launched, so it should always be there. And what I can do in this, this page here is get rid of this data access, and I'm just going to comment it out so you can see what used to be there. And instead of allocating this table dynamically, what we're going to do is retrieve it from the application data store. So I'm going to cache the result to a data table, and I'm going to index it, index into the application data store by saying application indexed by quotes table, and that should be it. Let's make sure our strings match. Quotes table and quotes table. Looks good. Okay, and the rest of this logic is just dependent on that table being retrieved and populated the same way it was before, which it already should be. So let's go ahead and try running this now, see if we get the same result. Okay, good. So there we are. We're running again. The difference now is the results from that query are cached in memory in the application object. And we're not going back to our database every time this page is refreshed from the server. So that definitely works. Again, I want to caution you, however, this code right here, while it looks innocuous enough, is going to be adding to the memory overhead of the worker process. And unlike the data cache, which we're going to spend an entire module discussing later, so please refer to that instead of using this technique, this will keep growing the worker process memory without any ability to recover data or to recover memory. So the cache will actually do scavenging to retrieve data. This will just continue augmenting the memory the more you use it. So in general, if you're doing something like this, let's put a warning in here. Use the cache for this instead. Okay, just so you remember. Prefer to use the cache, and that will actually prevent the worker process from potentially recycling if you end up using a lot of memory for storing things like this. Our next state repository is session state. And this is another one that you want to be a little bit careful with. It's often one that's reached for by developers that are used to working on desktop applications where they just have memory available to store on behalf of whoever is using the application. And the web, this is a place that sort of feels like that. It's a location of memory, a block of memory, that you can store information on behalf of individual users. So unlike application state, which was global across the entire application, session state is scoped per user, and that becomes a really compelling place to store data if you're trying to build web applications that are customized for individual clients. So we will talk about some issues that come up with session state, though. A lot of sites really try to avoid it completely for good reasons. And we'll share those reasons with you and also talk about some alternatives as we progress through this discussion. But let's start with just the basics of using session state. So session state is scoped to a single client. It is tagged by a unique ID. So each client that is accessing your site will have a session identifier generated on his or her behalf. And that session identifier is going to be transmitted by default via a cookie and will be used to index into the block of memory associated with that user on the server. So session state is always on the server, and it's always indexed by a session identifier, which is going to be unique per user that accesses your site. Now, the way you interact with session programmatically is there's a session property on the page class, which you can access it, and there's also one in the context object. So if you're not inside of a page class, you can always grab the session through the HTTP context.session property anywhere in your application. There's also a special event in global ASAX for initializing session data, and this is the session start event, and that's called every time a new user creates or accesses the site and is granted a new session identifier, you can initialize data on his or her behalf. So here's an example of something you might do with session. We are going to initialize some session state here to -1, and what we're going to do here is store the age of the user. So we'll start with -1, and if the user never goes to the page where the age is set, then that will be the default age. If they end up going to some page on our site which gives them the opportunity to set their age, we'll store that and update it here. So in this case, we're assuming the user has typed in an age for us, and we're going to store that in session. And then maybe that impacts how some other pages in your site work. And this is the convenience of session state. Notice I'm referring to it from 3 different places here. One in the application class, one in some page where I'm collecting data from the user, and one in a completely different page where I'm querying the user's age to enable or disable certain features on the site. And I'm talking about voting here, by the way, just in case your mind was elsewhere. So let's go ahead and try out some session state. In fact, let's do something very similar to the example on the slide. Notice we do have a session start event that is already in place for us when we added the global ASAX file. So let's go ahead and index session with age here and set it equal to -1. Okay, so that will be the default value for the user that comes in here. And let's go ahead and add another page to the site that's going to let the user set the particular, set the age. So set age, let's call it. And inside of set age, we're going to do an enter your age here. And for enter age, we're going to have the user type it into a text box. And I'll just name this age text box. And then down here, we'll print out, or give a button rather, so the user can add a handler, post back the data. So there's the button click, and let's go ahead and get the age by parsing the value that was typed into the text box. So age text box.text, and then we'll set the value of session equal to the age that we just calculated. Okay, and finally, let's go to one more page, the vote page, let's say. So there's our vote page, and the vote page is going to have a nice button on it that says vote. And what we're going to do is, in our code behind, we'll go check to see what the user's current age is. So int age is equal to int.parse of, actually no, we just cast it to integer, sorry. So we take whatever's in session, indexed by the age field, cast it to an integer, which is how we stored it. And if age is greater than 18, then button 1 dot enabled equals true. Otherwise, button 1 dot enabled equals false. Okay, so now we should have a little session information stored on behalf of users. And if we go ahead and run this page, let's try starting on the vote page. And since I'm not initializing my age, notice the vote button has been disabled. Now if we go back to the set age page, so set age.aspx, and type in a value here, something over 18, and go back to the vote page, we should see the vote button has in fact been enabled. Okay, so you can store data on behalf of users. And notice if I close out the browser, session by the state is a temporal repository. It goes away if the user closes the browser or if the session timeout, which defaults to 20 minutes elapses. So if I come back here to the vote page, notice I've been reinitialized to my -1 age, so the vote button has been disabled. And each client would have his or her own age stored in that session state. Now, I mentioned that session state is something that is often avoided by developers of web applications, and there are some good reasons for that. One is session state is temporal. It's always in memory on the server. So if you have a machine go down and the next request comes in, all the session state that was stored on behalf of a particular client is going to be gone. Also, it doesn't scale across web farms properly. So if you have, if you're using session state and you deploy your application to a web farm, so you have multiple machines, which any one of which may be servicing the next request coming in, the session state's not going to work because each request might end up on a different machine, which will have its own version of session state on behalf of each client. So that's a problem. Other issues are it depends on cookies to work properly. So if you have clients that have either disabled cookies or are using browsers that don't fully support them, of which there aren't many today, then your session state again will not work. So it can really, there's several points where the use of session state can break down depending on how you deploy your application and how your clients are configured. So one of the things they wanted to do in ASP.NET was give you some remedies for dealing with session state, and they've done exactly that. So here are a couple things they've done. One is you can switch to a mode called cookieless, and I'll show you an example of this in a bit. Cookieless will actually use an alternate technique for tracking session identifiers called URL mangling. So instead of granting a cookie to the client and storing the session identifier there, they will mangle the URL and actually embed the session key as part of the URL. So that's one thing they support. And then in version 2, they introduced a different mode called auto detect cookieless mode. So instead of just switching over to cookieless mode, you can actually say, well, try to use cookies, and if the client doesn't have cookies enabled, then fall back and use the URL mangling scheme. So that gives you an even more general approach to dealing with the cookie problem. There was a problem in earlier, not a problem, but an issue with earlier versions of ASP, classic ASP, where individual requests from a client would be serialized. So if you had concurrent requests and they all had a session identifier from one client, those would have to be serviced sequentially. That's no longer true in ASP.NET, so that's not an issue if it ever was one for you. The other significant thing is ASP.NET has introduced out-of-process session state. And out-of-process could also mean off-machine. So you can either have your session state stored in a local process running, or you can have it stored in a database, which could be either local or remote. And also you can configure it to store a session state in a remote machine in a dedicated process that's listening over a particular port. So they augmented the concept of session state to be across a network instead of just being local to a machine. And that works fine, although there are some potential performance implications there that we'll take a look at as well. And as of version 2, they made the whole system very pluggable. So it's easy to replace pieces of the session state architecture with your own implementations. If you find the mechanics of session state very useful in your applications, but you don't like some particular implementation on the back end in ASP.NET, it's not terribly difficult to go replace it with your own implementation. And we'll take a look at each of these things in turn and how they work in ASP.NET. And here's how you configure session state in ASP.NET. There's a session state element inside of the system.web element in your configuration file. Session state, by the way, must be configured at the root configuration file. You can't have this in a subdirectory. It'll generate an error. And then there are a number of attributes you can specify here that control various settings with respect to session state in ASP.NET. So let's take a look at some of those settings. Here's the cookieless mode that I was describing before. You can set this either explicitly to true, which means you don't want to use cookies at all, you just want to use the URL mangling, or you can set it to this newer feature called auto detect, which will attempt to determine whether the client has cookies enabled or not before deciding which mechanism to use to store the key. There's another option called use device profile, which probably isn't going to be very often useful because this looks at the browser capabilities and decides whether to use session state, session cookies or URL mangling based on the browser capabilities. And most browsers do support cookies. They have them. The issue is clients sometimes turn them off. So that is not something you can detect in the HTTP header, so this will not be reflected there. Other things you have, the mode here. So the default mode for session state is in process or in proc. You can turn it off completely, or you can elect to use one of the two external storage mechanisms, SQL Server or State Server. And that's what these two other attributes are defined for as well, where to go looking for that external state server. And we'll take a look at an example at doing that. Finally, you can change the timeout. So the default timeout is 20 minutes for session state. If you find that's not enough for your clients to do what they're typically doing, you can augment that, or of course you can always decrement as well. So let's go try configuring session state here. I'm going to open up my web.config file, go into the system.web element and specify a session state element. And let's try setting the cookieless mode to true, just to see how that affects the way this site works. Now, if you remember, we're storing the age of the user in session state right now. And what we should see when the first request comes in is the client does not have a session key yet. So what's going to happen is the client's going to be redirected to a new URL. And if you look at the site here, the address bar, you can see the session key was embedded in the URL that we were redirected to. And all subsequent pages in the site are going to pull out the session key from the URL and use that to index the session on behalf of the client. One thing you do need to take care of if you are using the cookieless mode is you need to make sure all of your URLs are relative in your site. And if you ever change the URL up here, make sure you don't touch the session ID, otherwise the user will get a brand new session identifier. So let's go to our set age page just to make sure everything's still working and try setting the age to 33. And now I should be able to go to the voting page, vote.aspx, and notice the vote button is in fact enabled. And so we're still getting session state on behalf of this client, but it's no longer storing the session identifier as a cookie, it's storing it in the URL. So we saw an example of using cookieless support, cookieless mode support in ASP.NET Session Management. And what that did was just mangle the URL to embed the session identifier. Generally, you want to prefer cookies just because they get in the way less, right? You don't have to worry about relative versus fixed URLs, and you don't have to worry about the client bookmarking your page with a URL embedded in it, a key embedded in it. So let me actually go back and show you how the cookie mode works, the default mode for session key management. So I'm going to take out this cookieless mode set to true, and let's go ahead and run the site again. And I'm going to bring up a debugging proxy, Fiddler, so we can take a look at the requests going back and forth and see how the cookies are being set. So the initial request that comes in from the client is going to be responded to with a request to set the session cookie, as you see right here. So there's the response to the initial request by the client, and it includes a call to set cookie with the session identifier. Now, if the client sets the cookie, the next request is going to include it. So if we go to vote.aspx, for example, then the next request here will, issued by the client, will include that cookie as part of the request. So here's the cookie the client sent back to us, and we use that to dereference his session state. Okay, so that's the standard mode of operation for session state. You just index it with a cookie and carry on, and you don't have to worry about URLs being changed. Now, the best of both worlds would really be, let's just use cookies, and if the client doesn't support them or has them turned off, then we'll go ahead and fall back on URL mangling. And that's exactly what auto-detect does. So the first thing you should know about auto-detecting is there's no real sanctioned way for finding out whether a client has cookies enabled or not. The best you can do is look at the session user agent string, the HTTP user agent string, and find out what browser they're using. And from the browser, you can find out whether the browser supports cookies or not. But most of the time, that's not the issue. The issue is whether the client has them enabled or not inside of the browser. And that's not something that's conveyed as part of the HTTP request. So the best you can do is actually try to set a cookie and see if it worked or not. And that's exactly what ASP.NET will do for you if you set the cookieless mode to auto-detect. So let me show you the sequence of events that will happen. The first request that comes in, ASP.NET is going to respond with a redirection, a 302. And the redirection is going to include a query string. So it just redirects the client back to the same endpoint. And the query string is going to be, wink, wink, we're in this auto-detect cookie mode. So we're going to check to see if this works or not. And we're going to set a cookie as part of the response, which is just a temporary cookie called ASPX auto-detect cookie support. So once we send that back to the client, we look at his next request. And if his next request includes the cookie that we tried to set, like you see here, then we know we're good. So we go ahead and set the session identifier as a cookie. On the other hand, if the client comes back with a new request that does not include the cookie, as you see in this scenario, so there's no cookie here, we're going to have to fall back on URL mangling. So we send another redirect, and this time we embed the session identifier in the URL, just like we did before. So either way, session state is going to work for the client. And we're going to prefer the cookie mode, so that's the least troublesome mode. But we will still support clients that don't have them enabled. So it's kind of the best of both worlds. Keep in mind, this looks like a lot of round trips here, but it only happens once the first time a new client comes in. All subsequent requests will either have the cookies set as we did here, or we'll have this URL with the embedded session identifier. So it's only on the initial request of a client that does not have a session key currently set. The other issue we talked about with session state that is often a problem is the fact that it's in memory in the server. And if that server kicks out for some reason and another request comes in, the session state goes away, even if the browser on the client has not changed and it still has the same session key. And perhaps the bigger problem is it doesn't work on a web farm. So if you deployed your application to a web farm with many machines, and each request can be serviced by a different machine, your session state is not going to track the user. So there are two different solutions to this in ASP.NET, both of which involve storing your session state externally from the web process. And the first solution is to store it in an NT service. This is just a standard Windows service that you can get up and running when your server starts running. And it will keep the session state in memory still, but it's going to be in a different process and potentially on a different machine. So it avoids it solves the problem of keeping the session state distinct from the web server process, and it also lets you isolate session state to a single machine on a network, which is then referred to by all of the web servers. Similarly, you can point it to an installation of SQL Server and have it store your data in session state into the SQL Server database. And there are a couple different ways of storing it. The default mechanism is to store it in a bunch of temporary tables for efficiency's sake, but it is possible to store it in some standard SQL tables if you want to take advantage of the full feature set of SQL Server, including things like clustering and such. Most of the time you want to be concerned about efficiencies though, so you probably want to prefer to accept the default of storing things in a temporary database. If once you do this, everything is going to be stored as an opaque byte stream, and this has a couple implications for you. The first of which is anything you store in session state must be serializable in .NET. Otherwise, it will not. It can't be stored out to the either the server or the database. And it's also going to incur a round trip, and actually a couple round trips per request to your state service, whether it's the in-memory service or whether it's the SQL Server installation, and then potentially to flush state. And we'll come back to this. There are ways of optimizing it, but do be aware that you are going to be incurring those round trips if you decide to store your session state out of process. So here's what it will ultimately look like once you're storing it out of process. Requests coming into a client, to a server from a client, will go out potentially to a database server in this scenario and retrieve the state for that client. And the state table has information about the session key and then data stored on their behalf. And that will be loaded into the web server to process the request and then flushed back out to the corresponding server. So next we'll take a look at doing each of these, using each of these techniques and actually demonstrating using state server and SQL Server to store your session state out of process. We're going to go ahead and demonstrate the two different techniques for storing session state out of process now. And let's start by using the state server. So first of all, you'll go into your session state configuration file element and specify the mode equal to state server if you want to use this out of process server. And then you're going to need to specify the state server connection string, which is how do you go to the server and retrieve and store data. And this is going to be in the following format. You're going to specify TCP IP rather, and the IP address of the server on which the state service is running. So in this case, we're just going to run it locally. So I'm going to use the loopback adapter, 127.0.0.1. And then you give it the port. And by default, the port is 42.42.4. Someone on the ASP.NET team obviously has a fondness for Douglas Adams. Anyway, that's how it's configured. That is something you can change if you want to. It's a registry entry, however, so you have to go to the registry and change the value. But that's the default port that the service will listen on. Okay, once you have that in place, you then need to go start the service on your machine that's going to be hosting it. So I'm going to go to my administrative tools here and bring up services. And once you install ASP.NET on a server, you should see this new service installed, ASP.NET State Service. And we're going to go ahead and start it. If you were going to do this for real, you'd probably want to change the mode of operation to this service from manual to automatic, so that every time the server started up, the service was running. Okay, so that service is now running. And just to demonstrate this, let's go ahead and run our site now. All of our session state is now going to be stored in that process. And you can see the process running here, the service. So there's the ASP.NET State service right there, listening on port 42.42.4. Now to show that it's working, let's go ahead and set the age of the client. So I'm going to set the age to 33 here. Let's go make sure everything looks good on the voting page. vote.aspx. Okay, so our vote button is enabled. That means the age was something higher than 18, so that seemed to work okay. Now what I'm going to do is stop the web service, the web server rather. And right now we're using the ASP.NET development server. So I'm going to go ahead and stop it. And then I'm going to go back to Visual Studio and launch it again. So this will restart the development server, bring us back to the same page without closing the browser. That's the important thing. So the client's session identifier is still the same, but the web server was essentially recycled. And the way we know that our session state is still intact is if we go to vote.aspx, the vote button is still enabled. So it remembered that our age was 33, even though the web server essentially died and came back again. So that shows that our state was being stored externally in the state server. And again, you could point this to any machine on your network that had that port open and was accessible. Now, the other option is to use SQL Server. And let's go ahead and do that now. So I'm going to set the mode to SQL Server. And instead of state connection string, I'll leave that one there for your reference, I'm going to specify the SQL connection string. And this guy is going to be the name of the SQL server. In my case, it's the name of this machine, which is Pluralsight SERV. And then the anything else you need to get to the database. So trusted connection equals yes in my case. Okay, notice I'm not going to specify a database name because that is inferred. You need to have the database schema and database name already installed, and it has to be the same name they're expecting. So that should be sufficient once we configure the database. So I'm going to go bring up a Visual Studio command prompt now to configure the database. And I'm going to run this utility called ASP.NET _reg SQL. And this is a generic utility that's useful for installing everything SQL related in ASP.NET. We're going to run across this several more times. Let me just get the help on this thing. And what we're going to do is use this last option here. So there are a number of options, but what we care about is the session state right now. So I'm going to use this feature right here, the -ss add. So let's go ahead and try that. So ASP.NET reg SQL -s to give it the server name, which is Pluralsight SERV, -e to use integrated authentication, and then -ss add to install the session state features. Okay, so if I bring up my database now, we should see that session state has been added to it, and I'll just show you that real quickly here. So there's the ASP state database, and you'll notice the state database doesn't have any tables. It's all done with temporary tables, but it does have a number of stored procedures in it, all of which are used to create temporary tables to store the state, session state on behalf of a client. Okay, so that should be up and running. Let's go ahead and try running our application again and doing the same test here. Okay, and the problem was I didn't type in server equals, so we needed to specify the server there. It wasn't prefaced to the server. And let's go ahead and try running that again. Good, so we're up and running. Let's go ahead and go to our vote.aspx page. And notice it's disabled. So let's go back to our set age page and change our age to something greater than 18. Go back to the vote.aspx page and refresh it, and we have access to the vote. Good, now let's go ahead and shut down the server. So I'm going to shut down the web server again, just like we did before. Go relaunch it from Visual Studio, which will bring us back to the home page. And again, the test here is to see if we can vote, because that means it will have remembered the age we stored in session state, and indeed it does. Okay, so both scenarios work fine. They store your session state externally to the web server and give you options for deploying to a web farm where you could point these things to a dedicated machine or SQL Server installation that maintained all of your session state. So we just saw an example of storing session state out of process using both the state server and the SQL Server examples. The only drawback, or I guess one of the drawbacks to using this technique, is it's going to incur a couple of round trips per request. So if you think about it, in order for pages to be able to use session state, they're going to have session state loaded from the data store prior to evaluating the page, and then they're going to have the session state flushed from the page to take any changes that were made by the user and put it back into the data store, whether it's the SQL database or the state server. So you're going to incur 2 additional round trips to an external data store, whether it's on the local machine or more likely across the network, per request. So that can start adding up quickly, especially if you have a lot of session state. It can incur more time to write it on the other side and bring it back and forth. So if you are going to use out-of-process session state, I would encourage you to go and analyze the session state usage on your pages. And what you can do is optimize how they use or how they retrieve session state using the enable session state attribute of the page directive. Now it defaults to true, which means it's going to incur both of those round trips for every single request. However, if you have some pages that don't touch session state at all, you can set the enable session state to false on it, and that will not incur any round trips at all. Or if you have a page that looks at session state, like our voting page, but doesn't actually make any modifications to it, you can set it to read only. In that case, it only incurs the 1 round trip to grab the session state, but it doesn't flush it when the page is complete. So again, if you're dealing with session state that's in memory, the default in process, this is not a big deal. The round trips are negligible. But if you are setting your session state up to be used out of process because you're deploying to a web farm or you're concerned about the temporal nature of it, I highly encourage you to go through your pages and optimize their reading and writing of session state using this attribute. So another mechanism you can use for storing state on behalf of individual clients is cookies. We saw cookies in use when we looked at session state. A cookie is the way that ASP.NET keeps the session identifier on behalf of clients, unless you use one of those alternate techniques that we looked at. But if you want to, you can use cookies directly yourself. However, be aware that you're subjecting yourself potentially to the problem of clients disabling cookies, and then you wouldn't be able to rely on them properly. So as long as you're comfortable that either that clients will always have cookies enabled or that your site will still behave well enough, or you don't care if clients don't have them enabled, then you can consider using them. Now, there are a couple things to know about cookies. As you store data in a cookie, it has to be a string. So if you're going to put any binary data in, you'll have to base64 encode it or something first. And there are 2 different collections of cookies. One is the cookies that you set in the response, and the other are the cookies that are sent by the client, which you can find in the request. So the client will send a cookie back to you over as long as the cookies are still valid before they time out. And you can decide how long a cookie lasts by setting the expiration on it. Browsers will theoretically limit you to 4 kilobytes of data, so you want to be careful not to put too much into the cookies. And also, like I mentioned, be aware that clients may disable them. So here's an example of using the cookie API in ASP.NET for modifying the cookie values. So what we're doing is looking at the cookies that are coming in from the client here and trying to find the age cookie. And if it's not there, we're going to go ahead and set it. And here's how you can set a cookie. You create a new instance of the HTTP cookie class and initialize it with whatever state you want it to store. It has to be a string. Set the value of the cookie to the string you want. And then add it to the collection of cookies that you're going to send back with your response. And that will be ask the client to set the cookie for subsequent requests. And then on subsequent requests, you can go ahead and access it just by looking at the value attribute of the cookies that are in the request collection. So next, we'll go ahead and try using a cookie to replace the session state example that we already have in place. So what I thought I would do to demonstrate cookies is go into our current implementation of session state to store the user's age and swap it out to store the age in cookies instead. So let's go ahead to our set age page where we're collecting the current age of the user. And instead of storing it in session, well, let's do this. In addition to storing it in session, let's go ahead and store it as a cookie as well. So what we're going to do is create a new HTTP cookie. Call this the age cookie. And we'll set its name to age. And we'll set the age cookie .value equal to, now this actually has to be a string, so I'm just going to take the age text box .text and put it directly into the cookie. So unlike session, which is in memory and can be whatever type you want, cookies have to have strings for their values. And then we're going to take the response object and its cookies collection, and we're going to add our age cookie to it so that the next time a request comes back, the client hopefully will have set that cookie with whatever value we requested here. Okay, so if we go to the voting page now, let's go ahead and change the retrieval from session to use a cookie now. So I'm going to redeclare age, and let's go find out, first of all, if the user has a cookie. So I'm just going to default the age to -1 in the case that, that the client has not set the age cookie. And let's go check. So I'm going to see if the request.cookies indexed by age is not equal to null. So there actually is a cookie there with age in it. Then we're going to set age equal to the parsing of the request.cookies indexed by age .value. So we pull out the string value of that and set the age equal to the parsing of the value, and that should end up being the same thing. Okay, so now instead of storing the age in the session, we're storing it as a cookie. The only thing that we really had to change in terms of our logic was the parsing, because we're storing this thing as a string. And also keep in mind that we are now round-tripping this data. So before, the age was stored in session, which was either in memory on the server or in another server on the web farm that we're deployed to. But with cookies, it's going back and forth as part of the HTTP header in the request and the response. So be aware that it is more visible on the wire if you're concerned about those things. Okay, so let's go ahead and try running this. And we'll go to our, well, let's test our first test our logic to see if the vote button is disabled if we don't set the cookie, and indeed it is. And let's go ahead and try setting the cookie by going to setAge.aspx, enter the age here, and then let's go to our voting button again and refresh, and there we go, it's enabled. Okay, so that worked fine. One thing I did want to mention about cookies, you can set how long the cookie is going to be valid for by setting the expires property on the cookie. So notice here we could say date time dot now dot add, new time span, and have this thing last for well, ticks is kind of silly. Let's do 1 hour, 0 minutes, and 0 seconds. Otherwise, you can set it to the default like we did before, and what that will do is just keep the cookie around for as long as the user keeps the browser open. So we've looked at session state and cookies as a way of storing state on behalf of individual clients that spanned many pages. Those pieces of state are available across the entire collection of pages in your site, no matter how the user navigates. Another useful place to put information is actually in the URL. And the way you can do this is using query strings. And I'm sure most of you have run across these before, but let me just quickly refresh your memory in case you haven't. Query strings are appended to a URL after the endpoint using a question mark to indicate that you're going to put query string values afterwards, and then placing name value pairs. And obviously they need to be strings because they're embedded in the URL, and you separate them with an ampersand character. So there's some restrictions on what you can put in here, even though they are strings. You can't use any of these characters you see on the slide here. So slash, dot, hash symbol, question mark, etc. Otherwise, you just pass them across, and then you can access them when you get onto the secondary page by going into the HTTP request object and pulling out the values. So very useful for putting your page into a different kind of state, maybe a selecting state to determine what is shown or not, or maybe just passing information about the user if they had it from the previous page. So here's an example of using a query string to pass information, including the user's last name and zip code. Now you do want to be careful about what you put into a query string because it's very obvious to the user that the data is going across request because you can actually see it in the address bar. So you don't want to put anything potentially private up there, and you certainly don't want to put anything where if someone changed the value, they could change the behavior of your site in a significant way that might expose features you didn't want to expose. So let's go ahead and try query string state here a little bit. Now to set this up, I'm going to create a new source page, just like so. And let's create a target page. So I'm going to set up a pair of pages so we can pass information from one to the other. This is going to be target.aspx. And let's go ahead to the source page and have the user so enter a name and enter an age, and we'll put in a text box to capture the name and age of the user, and let's put a break after each one, and finally we're going to put a button in which will actually initiate the transfer. And to save time here, I'm not going to bother renaming these controls, but obviously you do that in your real pages. Okay, let's go ahead to the code behind now. And when the user, actually let's add a handler for the button first. So when the user presses on this button, we're going to collect the values that they gave to us and send them back to a secondary page. So string name is going to be equal to text box 1.text, and then string or int age is going to be equal to text box 2.text, and we'll have to parse that to an integer. Although for right now, let's just keep it a string actually, because that's how we're going to have to pass it anyway. Okay, then we're going to set up a redirection. So I'm eventually going to say response.redirect to put them over to this other page. And let's go construct the URL for that. So string new URL is going to be equal to target.aspx. And we're going to concatenate onto this the query string, where we'll say name equals, and that'll be a placeholder, and then separator with an ampersand, and age equals placeholder 1. So we will populate that string.format and pass in name and age. Okay, so when we get to the second page, we should be able to pull out of the request coming in both the name and the age and maybe print it to the screen. So let's go to our target page, and let's just put a label on this page, which we will populate with whatever values are sent to us by the user. So inside of our load event handler, let's go in here and look for the name. So if you want to be careful with query strings, by the way, because users can always take them off. So you want to be prepared for the fact that the query string value might not be there, even if you are pretty sure that you set it. So we'll look for a request .query string indexed by name, and if that is not equal to null, then we'll go ahead and grab it. So string name, and we'll also do a string age. Okay, so if that worked, we'll do request dot query string indexed by name, and we'll just set that equal to name here. And then similarly, if request dot query string indexed by age is not equal to null, then we will set age equal to request dot query string indexed by age. Okay, let's clean this up a bit. In fact, let me make this a little bit more concise. Since we have this nice new syntax in C#, let's just do this. Set the string, set the name equal to this guy if it's not null. Otherwise, we'll set it to an empty string, and we'll have to cast this guy to a string. Okay, so same thing down here. Just set the age equal to casting this to a string, empty string, or whatever was sent back there. Okay, so now let's print it to the label. So label1.text equals hi there, name, you are age, years old. All right, so if this works, we should be able to see the information the user typed on the source page. So let's try running it and type in a name and an age, and that does a redirect, and there we are. Joe is 33. Now notice the values came across here. We can very easily go in here and change the values, and that will affect how this page renders. So again, that's something that is very useful for transmitting data, but it's also very out in the open, and it's easy for clients to make modifications to those pieces of data, so make sure it's nothing that would expose potential holes in your server. There's another collection of state that is less well known in ASP.NET called the items state collection. This is just a general collection of items, so it's name value pairs, that is stored in the HTTP context object. And each request is going to have its own distinct instance of HTTP context. So it's a per request state bag that you can use to pass information. Now, this often strikes people as odd, that it doesn't seem like it would be very useful if it's all in the context of the same request. But if you combine this with a server.transfer to move from one page to another without actually leaving the server, that can be useful. And also for just passing data down between elements in the pipeline. Like if you wanted to add a handler for the begin request event in a module or your application, you could put data into the items collection and make it available to all the pages in your site. So I have here an example of using the items collection to pass information from one page to another using server.transfer. Let's go ahead and try to do something similar in the example we just were working on here. So I'm going to go back to our source page and change the implementation from using the query string to using the items collection. So let's change this right here. So we're no longer going to use the response.redirect, but instead we're going to use our context.items collection and index it with a name and set that equal to the name that we grabbed, and then context.items index by age, and we're going to set this equal to int.parse of the age. Now in this case, we're not constrained to storing strings here because this is just a in-memory collection of name value pairs that's going to be around for the duration of the request. So we don't have to worry about putting things in as strings. And now if I do a server.transfer to our secondary page, which was target.aspx as opposed to response.redirect, once we get over to target.aspx, we should now be able to pull out these values. Instead of from the query string, we're going to pull them out from the items collection. So string name is going to be equal to a string of context.items indexed by name, and int age is going to be equal to a string of context.items indexed by age. And now these should print out essentially the same thing, although we're going to have to cast this age or turn this age to a string in order to properly concatenate it with the surrounding content. Okay, so let's go ahead and try running this now that we have everything stored in the items collection. Whoops. So we need to cast that to an int, not a string. That would help. Okay, so let's go ahead and try running our source page and seeing if the data is in fact propagated via the items collection. So we'll type in our name here, put in an age, go, and we're on the target page. Now the one significant difference between these two techniques, the query string and the items collection, is you'll notice that the address bar has not changed to indicate that we're on the target page, because we did the redirection on the server and just sent back the response as if the user had accessed the target.aspx page. So that will change once the user interacts with this page if we had some server-side controls, or moves on to the next page. Now, the one other thing that you might find useful about the items collection is the ability to store data that is accessible to all of your pages. So here's an example. Inside of a handler in your application class in Global ASAX, we could add a handler for begin request, which takes an object, source, and event args E. And inside of here, we could put something into the items collection. So imagine you're going off and finding a piece of data, or you have information about the request from the user, or the user's been authenticated and you want to put his name in here. Any of those scenarios would be interesting. I'm just going to go ahead and use context.items and pass in user name maybe. And for this case, I'm just going to hard code it to Bob. But that's where you would go off and do something interesting to find out this information. And then what I can do in the rest of my site is, let's go to the source page, for example, and maybe we want to pre-populate the value of that name text box with the user's name. So I can say textbox1.text if we're not in a post back. We'll populate it with the items collection, context.items, with username as the index. And because that will have been set in the begin request event of the application class, it will always be there, and we can just pull it out and use it wherever it makes sense in our application. So this time when we run, notice the name field is pre-populated with Bob because that was set in our application begin request event. So a couple of useful things you can do with the items collection. It's worth pointing out that the view state repository that we discussed in the control-based programming module of this course can be used for arbitrary state as well. The scope of the repository is going to be posts back to the same page, however. So the only place where using view state makes sense is when you're on a page that is posting back to itself and you want to keep information around between those postbacks. And this is basically what controls use it for, but you can also use it for your own purposes if you want to. So I have an example here just to give you an idea of something you might consider doing. In this case, I assume that in a previous post we have populated an array list in this view state collection, and we've named it cart. So what I'm doing is when the page is being loaded, if we're in the middle of a postback, then I go look into the view state and pull out that cart. And this is showing you, how much you can actually put into view state. It's not just, strings or simple primitive values. You can actually put entire data structures as long as they are serializable so that they can write themselves into a byte stream and have that byte stream encoded using base64 encoding to place it into the view state repository. So anyway, if this array list comes back as a valid list, then we can start accessing it and working with it and using some of the content that was stored there. So across posts to the same page, you can also place things as name-value pairs into the view state collection. One of the most common techniques for propagating information from one page to another is cross-page posting. And I don't mean common in ASP.NET because it actually hasn't been possible in ASP.NET until version 2. They actually essentially prevented this technique in earlier versions of ASP.NET, starting with 1 and 1.1. And the reason for that is the ASP.NET page architecture is built around a server-side form element, and that is dependent on the form posting back to itself. They take control over the action property of the form element, which is what you would traditionally set to point a form post to go to a secondary page. However, as of version 2, they have reintroduced support for cross-page posting, but it's slightly different from what you might be used to in other environments. Instead of setting the action on the form element, which is what you would do here, there's a new attribute on controls that generate postbacks, like a button, called postback URL. And what this will do is dynamically modify the action element on the form for you and point it to whatever endpoint you specified as the postback URL. So it's a convenient way to set this up. It's easy to, for example, create multiple controls that actually target different endpoints on the same page instead of hard coding your form to go to one place. And it also has the convenience of being wrapped up with ASP.NET's server-side control model. So let's go ahead and try this out. Let's try postback, cross-page postbacks here. So I'm actually going to go back to the same source page and target page pair that we've been working with. So we have the one where we're entering information from the user, the name and the age, and the user's pressing this button to submit the data. And the way we last left it was we were performing a server.transfer and placing items into the items collection. So I'm going to comment that implementation out. And instead, I'm going to go ahead and have this perform a transfer or a postback to a secondary page. So instead of posting back to this page, which is what the button would traditionally do, we are going to have it do a direct post to the target page, and then we'll be able to pull the values out from the request as it comes over. So let's go into our source.aspx, and what I'm going to do is actually remove the handler for onClick and change this to be a postback URL, and we're going to point that to our target page like this. So what this will do is it will take all the input elements on our form and send them across in a post request to this endpoint right here. And once we get to that endpoint, we could pull the values out. So let's go over to our target page now, knowing that we're going to be the target of a cross-page postback. And again, I'm going to comment out these two, which were retrieved from the items collection, because that's no longer going to be the case. And instead, what I'm going to do is look at the values in the post body. So let's go ahead and inspect it. I'm going to look at the request indexed by, and the index of the request is going to be the name of the element in the source page. So in the source page, we had two elements. In fact, well, we'll leave them like this for now. Text box 1 and text box 2. So text box 1 is going to be the identifier that's used to name the input element in the client and for the name, and text box 2 is going to be the one for age. So let's go ahead and do that. Grab the one for text box 1. So if there is a value inside of text box 1 in the request object, then we're going to pull it out and set string name and int age. And we'll pull it out of the text box here. So we'll say a name is going to be equal to a casting of a string of the request object indexed by text box 1. And if request indexed by text box 2, so we found a element in the post body with that name on it, we'll go ahead and set the age equal to an int parse of string request indexed by text box 2, like so. Okay, so, and then the rest of our logic should work fine since we used the same variable names. Okay, so this is the first approach I'm going to show you. Let's go ahead and start with our source page now, and then try running and posting across to the target page. So I hit the button, and notice it posted back to the second page, and the second page was able to pick out the values in the post body. And just to show you how that traffic works, let's go ahead and bring up the Fiddler tool and trap the traffic between the two pages here. Let's put in the value and do the post, and let's go take a look at that request as it came across. So inside of the request, we can see it came across as a post request. There's the post request to the target.aspx file. And down below, let me scroll down here, we can see the post body. And the post body included all of the input elements on that page. And the ones that I was interested in this particular case were text box 1, which you see right here, and text box 2, which I pulled out of the post body and used them to render the second page. Okay, so that's kind of the simple way to use it, and that works fine. You can do that. However, what we've done is we've pretty tightly coupled our page here, our target page, to look for those text box 1 and text box 2 post body variables. Now it turns out ASP.NET is actually supports a bit more than this if you want to take advantage of it. And the way it supports a bit more is a page that is being posted to from another page will have access to a property called previous page. And this previous page property will be pointing to an instance of the previous page, which will have parsed the post body for that page. And the reason that's important is while this technique here works fine for simple post body variables, it would not successfully parse the view state, for example. So if you placed something into the view state, the only way to extract it would be to go through the previous page object and pull it out that way. So what I thought I'd do here is comment this stuff out and change this to use the previous page and pull the values out in a strongly typed fashion. Now the only problem is the previous page right now is simply a reference to the previous page object, and the type of this guy is simply system.web.page, so we'd have to sort of drill into the control hierarchy to use it. So what I'm going to do is go back to my source page and actually define a couple of properties that I want to expose to the target page. So I'm going to create a read-only property that is going to return a string, and we're going to call this name, and I'm going to implement the name property to return the value of textbox1.text. And we'll do the same thing for age, except let's go ahead and make this strongly typed to an integer, and we'll return the int.parse, which you'd want to add some error handling to if you were doing this for real. And we'll grab the value out of the text box, the second text box, and parse it to an age. Okay, so now if the target page receives this post back and the previous page is there, we should be able to reach into those properties to pull the values out, and that'll give us a much stronger typed way to access the values. However, notice what happens here. If I go in and say previous page dot, there is no name property here, and as well as age property. And the reason for that, of course, is that the previous page is in fact typed to the System Web UI class, so it's not strongly typed to our source page, which is what we wanted. Now, if you are going to be using just one page to post to this secondary page, you can go into your target page and tell it with a previous page type directive which page you're being posted from. So I can say I'm always going to be posted to from source.aspx. And what that will do is give you a strongly typed wrapper on the previous page object, which is strongly typed to the source ASPX page. So now, when I access previous page, we should see all of those properties that I just defined. So there's the age property right there. We'll just set age equal to that. And the name property is going to be in previous page.name. Okay, so that's a nice model where you get the previous page typing, strongly typing with the values that were stored or available in the previous page. Now, the one thing you might want to check here is to make sure that you're in the middle of a cross-page postback. And the way to do that, the safest way to do it is just the following: check to see if previous page is not equal to null. And if it's not equal to null, then we'll go ahead and use all that information to populate the label. If it is equal to null, we were somehow we arrived at this page without going through the cross-page posting, so we'll just leave the label blank and continue from there. So let's go ahead and try this page again, running the source page, and we'll fill in the name, do the cross-page post, and there we go. And the traffic will look pretty much the same on the wire, but we have this nice relationship now where you can actually define properties in the source page and access them on the target page in a strongly typed fashion. There are a couple notes I wanted to point out on this cross-page posting mechanism in ASP.NET that you should be aware of if you're going to be using it. One is the previous page is actually going to be executed as if it were posted to up until the load complete event of the page lifecycle on the processing of the cross-page post. And let me just go ahead and demonstrate this real quick so it's very clear what I'm trying to describe here. So to show you what's happening, I'm going to go into my source page. And inside of the source page, I'm going to bring in system.io so I can write out to a file. And what I'm going to do is every time this page is processing a request, I'm going to write out to a log file. So I'm going to use, actually, let's just do this. File.append all text, and we'll do a server.map path of ~whack log.txt. So we'll point it to a local file in our little directory here. And I'm just going to print out an indicator that this page was actually hit. So page was accessed. Okay? So that'll just be a little log that we're writing out to the file system every time this page is running. So let's go ahead and run our site now. So I'm running for the first time here. Here's the first page, so we should have hit that load event handler, which should have written to the log file for the first time. And then I post to the secondary page, and this is when our target page was processed and referenced the previous page to pull out the name and age properties that we exposed. Now, what you might find surprising, if you go back and look at this log file that we just generated, is that we got two indicators that the page was accessed. Okay, and the reason for that is on the target page, when it was processing the cross-page post, when we accessed the previous page property of this guy, it actually instantiated the previous page and walked it through the page lifecycle, pointing it to the request body so that the post body variables could be processed by the controls they were designed for. So this is sort of an artifact of the way cross-page posting works in ASP.NET. By the way, if you don't ever reference this previous page property, it will not go through the previous page lifecycle, and I would not have had that second access. The reason I like to point this out, so in general, that's not a huge deal, right? But the reason I like to point it out is if you're doing something, let me just delete this. If you're doing something with side effects, like I was there, that I expect to happen only when this page is actually serving as an endpoint to a request, you may want to caveat it or exempt it from happening if you're in the middle of processing a request for the purpose of a cross-page post. So I could do it here. I could say if is cross-page post back, then we're not going to bother doing this. I'll do a negative conditional. So if it's not a cross-page post back, then we do write out to the file. If it is a cross-page post back, we don't do anything. So you can use this Boolean value to figure out if you're just being used to process a request on behalf of another page, or if it's a real request that you yourself are processing. And if we try this one more time, notice I deleted the file, so we're starting from scratch again. And do the cross-page post and go look at the file that's generated. We should see only one entry this time. Good. Okay, so that's one point I wanted to make. Another point is that you might find it useful to use this cross-page posting in combination with viewState. So you can actually use viewState and expose a property that pulls a value out of viewState, and it's a very easy way to put data, propagate data from one page to the next using the viewState repository, which is usually only reserved for passing data back and forth to the same page during a postback. So keep that in mind. Cross-page posting can actually work as a mechanism for cross-page state propagation if you're using cross-page posting. One other thing to keep in mind is that server-side validation is going to be happening after the post back on the target page. And again, if you think about this, the reason that's the case, let me go ahead and demonstrate this to you real quick, is the source page is not going to be processing the post body variables until you get to the target page because of the nature of the cross-page post. So let me show you a potential problem with this. If I want to make sure that this age field is always entered, I might add a required field validation control to it and put in a little indicator that something is wrong if you didn't add the field. And let's go ahead and set the control to validate equal to text box 2. So that's going to force people to populate the age field before it posts across. Now, if you have client-side validation enabled and the client has JavaScript, which is what is on by default, then everything works fine. There's nothing to worry about. So notice here, we get our error indicator. However, if for some reason the client does not support the client-side validation, then you'll find that the value coming back across is not going to be validated. So I can simulate that by going in here and saying client target equals down level. And all this does is send a artificially it pretends that the browser that's currently accessing the page is unrecognized. So we assume the worst case scenario where it does not support JavaScript and other features. So if I just run this, notice what happens when I go to the target page without filling in the age field. We're going to get an error because I tried to parse the value during the post-processing. So what you want to do is before you access any values in the target page or in the source page when you're on the target page, make sure that it's valid. So if it's not null and previous page dot is valid, so that will check to make sure that all of the validation controls have passed their requirements, then we actually do some interesting stuff. Otherwise, you might want to put a message up. Let's do this. Else if previous page dot is valid is not valid, then we'll do label one dot text equals invalid data entry, and you might want to put a little message that says please go back to the previous page or something to that effect. So let's go ahead and try running this now. Whoops, after I fix that problem. Label one dot text. Okay, go to the source page. Let's try that. Okay, so we add do the age. Oh, that wasn't what I wanted to do. Let's go back. Let's take the age out and try submitting it across. And notice we got our indicator that there was invalid data. So keep that in mind as well, that validation doesn't happen until the previous page is actually processing the post body, and that happens when you reference the previous page property in the target page. And finally, we arrive at profile. This is a per-client data store that was added in ASP.NET version 2. And the best way to think of profile is think of it as session state that is always persisted, so it's always backed up by a database, and it's strongly typed. So remember, session state by default was always accessed via name-value pairs where the values were always objects. Profile always gives you a strongly typed access to the values that you store in it. And you also need to configure those types to place them in. So it's backed by a provider, and the provider maps onto a specific database. By default, it will map onto SQL Server. It supports both anonymous and authenticated clients, and this is another interesting difference between session state and profile, is that profile is aware of clients that are authenticated either with cookie-based authentication or integrated authentication in ASP.NET. And if they are authenticated, it will just use their user ID to index their profile data store. If they're anonymous, and you've granted permission for anonymous users to store data, it will use their anonymous identifier, which is generated for them much like the session key is. And that's different from session because session always generates a new key for every user, regardless of whether they're authenticated or not. It is completely independent of any authentication mechanism. So that's another nice reason to consider profile, is that it's aware of your authentication scheme and it takes advantage of it, so it doesn't continuously generate new identifiers for everyone unnecessarily. Okay, so let's just go ahead and try using profile here to get started. And let me start kind of from scratch here by closing the windows. And what I'm going to do is create a new page for setting profile data. So let's call this page set profile. And what I'd like users to be able to do is set a couple of pieces of information about themselves. So let's do our typical enter a name, enter age, and enter color. How about something a little different here? And I'm going to put in break after each one, and similarly, like we've been doing previously, I'm going to put a button in to set the profile value, and set profile. And let's put in a text box to store each of those properties. So there's the name, there's the age, and there's a color, which I want users to type in. Okay, now before I go about collecting this data, let me show you what you need to do to configure profile for use in your application. So we're going to go into our web.config file, and I'm going to go down inside of system.web, where we've been exploring, and I'm going to place a new element in here called profile. And we're going to enable it. So set enable to true. And then what you do inside of profile is you specify a number of properties. And this is where the strong typing comes in. So you add a property, give it a name. I'm going to start with name. Give it a type, and this is a .NET type. So we're going to use string, and give it a default value if you want to. And we'll just leave an empty name. And you can also specify whether anonymous clients are allowed to store this property or not. And then I'm going to add the age one and set the type equal to an int and set the default value equal to -1 and allow anonymous to true. And finally, the color, and we'll set the type equal to, just keep it a simple string for now, default value of, how about corn silk? Lovely color, shouldn't offend anyone, and allow anonymous to true. Now, if you are going to support anonymous users storing profile data, you need to make sure you enable the anonymous identification feature of ASP.NET. So you specify allow anonymous identification enabled equals true. And we'll talk more about that in a little bit, but that basically sets up the automatic ID generation for clients that are not authenticated. Okay, so let's go back to our profile page now where we were setting it. And inside of our page, our handler for the button here, so I'm going to go to Design View and add a handler for the profile button. Let's go ahead and set the values. And to set the values, there's a strongly typed profile object, which you'll see in your IntelliSense, which has all of the properties you defined in your config file available for access. So I'm going to set the name property of profile equal to text box one.text, set the age property equal to an int.parse of text box 2.text, and set the color property equal to text box 3.text. Okay, so that's how we save it. And just to show you an example of retrieving it, let's actually pre-populate these boxes here. So if it's not a postback, we're going to populate all of the profile values with whatever values were stored in profile. We're going to populate the input, the text boxes with those values. So I'm going to grab these guys and change the assignment to be the other direction, like so. By the way, if you haven't seen that Alt select feature in Visual Studio, that's rectangular selection, just hold the Alt key down while you're doing the selection, and it will give you a rectangular selection block instead of the standard linear one. Okay, so, and then I change this as well. So the text box is going to equal profile age dot toString. Okay, so let's go try running the page now. Now, the first time we run this, it's going to take a few moments to launch, and I'll talk more about why this is in a few minutes and look at some details. But here we are, we're running. So let's fill the values in. First of all, notice that the text boxes were pre-populated with default values that we specified in our config file. So that's a good sign. It looks like it's working. So if we fill in some values here of Joe, 33, and Blue, and set them, and then let's go do a quick refresh on the page as a fresh request. Notice the values are all stored there before. And just as another test, let's go ahead and close this out. This is another distinction from session state, is that profile is persistent by default. It will actually persist across sessions in a cookie that is stored on disk, or just by using the user's identifier with its authentication. So our values are in fact retained across visits to the site here. Okay, so that's the basics of using profile. Setting up the property definitions, setting up the strong types, enabling anonymous identification. And the reason we had strong typing, by the way, is inside of your page class, ASP.NET will generate this strongly typed profile object based on your configuration file entries. And that's why we were able to say profile.color and profile.name without having to do any casting back and forth. The casting was done implicitly for us by the strongly typed profile object. Now, the thing you're probably wondering right now after seeing that first example of using profile is, where is that data being stored? Because we didn't set up any configuration, we didn't point it to a database, but somehow it was able to keep user profile information around between requests and between users of the site. So it turns out ASP.NET will generate a database. This is kind of the Miranda of databases in the .NET world. If you don't have one, one will be provided for you. And the database is a local SQL Server Express database that is just dropped into your app data directory, and it is pre-populated with a bunch of ASP.NET tables that will store profile information. This is also used for several other features of ASP.NET, including the membership feature, as well as the web part serialization, and others that we will encounter down the road. So profile is stored in a table, as we'll see, called ASP.NET_profile, and it has property names and then the corresponding values, and I'll show you the format that they're all stored in. And the profile data store is indexed by a user ID, which comes from this table right here. And the user ID is either an anonymous user, in which case this flag will be true, the is anonymous, or it's an authenticated user, in which case the membership table, if you're using cookie-based authentication, will have a corresponding user ID identifying the actual user that is accessing the data store. So if you want to take a look at that, we can go back to our site here, and if we expand our app data directory and do a refresh, you'll notice that the ASP.NET DB database was spit out right there. And if we drill into the database, you can look at the profile table, and we should see some values that we stored there in our last demo. So you can see the way it works. It's going to have a single row per user, and this is generally the way profile works, is it stores all of the values for a given user in one single row. Now there are a couple ways of storing values, which I'll mention in a moment here, but by default they're just stored as simple string values, unless you're talking about more complex types. And the string values are stored with a just concatenated together, and the property names indicate which fields are where at various indices that are stored in the property names column. Now it's worth noting that the examples I showed here were very simple primitive types, but you can use pretty much arbitrarily complex .NET types. I mean, you could store strongly typed list collections of person objects in here if you wanted to, and by default, the serialization that it will use, unless you change it, is going to use the XML serializer to store that data into the database table. If you do want to change it, however, there's an option here in the properties. As you specify a property, you can specify the serialize as flag, and one of the options here is binary. So binary is actually going to serialize it into a binary data store using the standard .NET serialization mechanism. And if you do that, it will store that particular property in the binary field, this column right here, the property values binary, and it will be written out to the database there. So it's a pretty robust engine for storing values. It saves arbitrarily complex .NET objects in there if you need it to, and of course simple property values as well. One other thing that's worth mentioning about profile, in contrast with session state, if you recall, we had that issue with session state round tripping back and forth to the state server and the SQL Server database to retrieve the information. Profile is a lazy read and a write on change only implementation. So it will not retrieve data from Profile unless you actually ask for it, at which point it goes out to the database and returns all the data for that particular user. And then it doesn't write the data back to the database unless you make a modification to values in the Profile data store. So that logic is built into the Profile infrastructure, so you won't make unnecessary round trips to the database. One of the features that Profile relies on to work properly is the support for anonymous ID generation in ASP.NET. And this is a useful feature to be aware of even outside of Profile. If you're not using Profile, but you want some way to identify clients coming in, this will save you the trouble of having to set up your own unique identifier generation mechanism, as well as setting up the cookie to store the identifier for them. And I should point out that this anonymous identification also supports all the same cookieless modes that the session keys do. So you can specify a cookieless mode of true or auto detect if you want to. So the way this works is you enable anonymous identification in your config file like we did earlier. And even if you're not using Profile, you can come in here and access it through the request.anonymous_ID. So that gives you a way of accessing anonymous identifiers on behalf of clients. If the client is authenticated, the anonymous identifier will be blank, so you can tell the difference between the two. This brings me to another point that I find very useful about Profile. Let me demonstrate this for you. I'm just going to go in. First of all, we have anonymous identification enabled here, just to show that to you. Remember, we did this earlier in our Profile example. So we have anonymous identification enabled. So if I want to, I could go into, let's just go to the home page here and drop a label on where I'm going to print out some information. And inside of my code behind, let's do the following. Label 1.text is equal to request.anonymous ID. And what that should do is print out the anonymous identifier associated with the running client. Now it turns out we're currently using the ASP.NET development server. So what we're going to see is nothing in this case because the development server runs under your credentials by default. So whatever I'm logged in as is going to be the user I'm running under with integrated Windows authentication. So notice we don't see any anonymous identifier here. But if I want to see that, I could set up a new application inside of IIS. Let's go ahead and do that real quick here. So I'm going to go to my website and add a application and just call it Profile, and we'll go point it to the directory we've been working in here. So this was State Management Demos. And if I go run the site from this location, now I'm going to go ahead and shut down Visual Studio before we launch this, just to make sure there's no contention for that database file. And let's go ahead and launch this, and IIS by default should have anonymous identification, or it should allow anonymous access unless you change it. And there we go, we see the anonymous identifier. So what I wanted to show you is that Profile has another property that you might find useful. Again, even if you're not using the data storage mechanisms in Profile, it's useful to have a unique identifier for all clients, even if your site supports both authenticated and anonymous clients. And you can get exactly that if you reach into the Profile username property. And what this is going to be is either the anonymous identifier that's specified in the request object from the anonymous ID feature, or it's going to be the username of the client that has been authenticated. And I can show this to you if I run within Visual Studio, which we know is going to run under my authenticated identity. Whoops, I need to bounce the worker process or the app pool so we get a release on that database file. Okay, so if I run it within Visual Studio, you'll see that username of the Profile object defaults to the identity of the client that's been authenticated. So that's nice. And then if you go back to IIS and run it from here, let's go back to our Profile application and launch this. Now that same property is going to show us the anonymous identifier. So you have one variable, the profile.username, which will resolve either to an anonymous identifier if you've enabled it, or to the actual identity of the client. So you might find that useful even if you're not taking advantage of profile property storage. If you end up using the profile data store to persist information, especially for anonymous clients on a public-facing website, you do want to be careful to clean out unused profiles after periods of time. Otherwise, you have the danger of growing your database unnecessarily large with a bunch of stale data that's no longer used. Now, fortunately, there are some existing stored procedures that are built into the database you could use. And you can either build up, for example, a SQL job to go run these stored procedures and clean out inactive profiles after a period of time. Or there's a useful class called Profile Manager that you can use. And this has a couple of useful functions on it. You can delete profiles explicitly. You can find profiles by username. And you can also delete inactive profiles either for anonymous and or authenticated clients over a period of time. So what I often like to do, and let me just go ahead and demo this real quick, is create a management page. So let's just create a new administrative directory for our website, which we'd probably secure. And let's add a new web form called Manage Profile. And I'm just going to keep this simple and drop a single button on here, delete inactive profile or users. Well, let's keep it clear, profile. And let's add a handler for the button. And what we'll do is use that profile manager class, which is in system.web.profile, to call delete inactive profiles. We'll specify an authentication option of all. Notice you can choose to either delete anonymous, authenticated, or everyone. And let's go ahead and set a the next parameter. Let's just get the IntelliSense back here. The date time back to which you want to check. So I'm just going to do something like this, date time dot now. I actually want to clear out everyone from the profile data store. So if we go ahead and run this page and delete the inactive profile, we should see a clearing out of profile data stores. And we can go open up our database to verify that, our local database. Take a look at the profile table and open up the table data. And notice there are no more profile entries in here, whereas before we had the single entry for the authenticated user. So keep that in mind. If you do end up using profile, you'll probably want to either build a little utility application or write an administrative page or something to make sure your profile database tables are not growing unwieldy and too large. The last thing I wanted to touch on in profile was how to change the database where it's storing its data. By default, as you saw, it stores the database to the local SQL Express database in your app data directory. And it's not too often that you're going to want to deploy a site that relies on that Express database. It's more likely you'll want to push it out to a full-fledged SQL Server implementation or deployment and manage it like you manage other databases in your site. So to do this, you first of all need to prepare a database to store the information. And we're going to go revisit that utility that I showed you earlier, ASP.NET Reg SQL, to populate the target database with the correct schema. And then you need to point profile to your new database. And the way to do that, the simplest way to do it, is to go into your connection string settings, take out the local SQL Server connection string, which is the connection string that's used for all of these ASP.NET database related features, including profile and membership and web parts, and point it to your new database. And this can either be a database you've already got up and running, or you can create a brand new database just for the purpose of storing ASP.NET's data. So let's go ahead and try doing that. I'm going to first of all create the database. So we're going to go run this utility again, ASP.NET reg SQL. And it turns out if you run it without any command line parameters, it'll bring up a little interface for you, which specifically will generate a new database for ASP.NET. So I'm going to click on Next and say Configure SQL Server. And let's go ahead and accept the default server here and use integrated authentication. And this will generate a new database in my local SQL Server installation. So if I bring up SQL Server, we should now see a database called ASP.NET DB. Now, like I said, if you want to, you can actually run this utility against an existing database. And you should be safe because all of the tables are prefixed with ASP.NET. So unless you have the habit of defining tables that look like that, it should be able to co-locate with an existing database. Also, there are a number of stored procedures in here as well. If you just want to see how some of those methods are implemented. So that's the database. Now, to point to this new database, we need to go into the config file and let's swap out the connection string. So just like I showed you in the slides there, I'm going to remove the named local SQL Server database, and I'm going to add it back in again, local SQL Server. Make sure you spell it with the right capitalization and everything. And I'm going to specify connection string of server equals plural site serve, and trusted connection equals yes for integrated security, and finally database is going to be equal to ASP.NET DB. So you set up the connection string to point to that database, and now when we run this application, it will no longer be relying on that local SQL Server database, but instead, if we go to set profile, so Joe 33 and blue, this should be written to the local SQL Server installation, which I can check here by bringing up the profile table and running a query against it. So let's just do a select star from ASP.NET profile, like so. And then down here, we see that we've got property names and property values, just like we had before in our local SQL Express database, but now it's in the full-fledged SQL Server 2008 in this case. The last state-related feature that I wanted to touch on is a pair or a couple of controls that you can use for achieving something very similar to page-to-page navigation, but doing it all within the same page. And both of these controls model something that's a pretty common technique in web development in general, which is to create a number of panels on a page, either using divs or some other HTML construct, and then toggling the visibility of individual panels based on user interaction. So think of like a data collection of a user's name and address and preferences. You might have multiple divs on the page, and you just flip the visibility of each div as the user presses a button to indicate that he's finished adding data. So there are two controls that help you with this. Well, three actually. The wizard control is kind of a pre-built packaged wizard control that gives you next and previous and finish, whereas the multi-view and view pair give you sort of raw or finer grained elements for building something very similar. So let me just show you an example of each of these controls, and you can try them out on your own. So I'm going to go back into our website here and add a new page for multi-view wizard, we'll call it. And what I'm going to place on the page is an instance of the multi-view control. And the multi-view control is going to be a control that houses multiple views. So inside of the multi-view, we place one or more view controls, which I can drop in like this. Oh, can't quite do it that way. So let's do it like this. So view goes in here. That's always safe. Okay, so I've got three views, and what I'm going to do is put something different in each of the respective views. So let's put a button in the first view and a text box in the second view, and you can sort of get the idea of things you might be able to do. And let's set the property of the label, or the text of the label, to just some text so we can see it. Okay, and now what you need to do is give the user the ability to flip between views. So I'm going to just put 3 different buttons at the bottom here, and we'll let the user click on a corresponding button. So this is completely up to you how you do this, how a user will transition from one view to another. But I'm going to do it with a series of buttons. And what we'll do with a multi-view is set its default view initially to 0. So that's the first one we're going to see. So active view index is going to be set initially to 0. So that's what you see when it first runs. And when the user clicks on the first view button, we're going to say multi-view 1.activeViewIndexed index is equal to 0. And then we'll do the same thing for button 2 and button 3, except we will flip it to the corresponding index of the view we want them to see. Okay, so there's my interface. Should be ready to go. Let's try running it. And as you flip from view 1, which we're currently in, to view 2 to view 3, notice it changes the which panel is actually being displayed. And the advantage of this is you keep the user on a single page, so all of the state for all of your controls that you place within these views is available to you in your server-side code. It's retained via input elements posting back and or view state, so you don't have to worry about using any supplemental state mechanisms like we've been talking about. And just to finish the example here, the wizard control gives you more of a pre-packaged implementation. So I can go here and drop the wizard control on. And the idea with this guy is you can put something in each step of the wizard. So let's put a text box in the first one, flip over to step 2, and put a button in the second one. And notice by default it's going to give us previous, next, and finish buttons. And it's all customizable. You can use templates to customize it. You can add event handlers for each of the various triggered events that you want to capture. But it's something you could build from the view multi-view pair of controls if you wanted to do it by hand. So here's that wizard control with the various pieces in place. Previous, next, and finish just fires an event. So we've looked at a large number of options in this module for places to put data that you want to keep around in your application. Let's just do a quick recap on each of these various collections and talk about their scope and some of the pluses and minuses. We started off with a look at application state, and we warned you that it can limit scalability if you overuse it. It's not shared across a web farm, and the data cache is usually a better choice, and we have an entire module dedicated to the data cache, which I encourage you to check out if you're looking for a way to store global data read-only efficiently. But it is a simple way to store information that's available across all your pages and across all clients in a single application. Session state was more interesting. This was a per client data collection, and you can configure it in ASP.NET to be shared across machines in a web farm. It does require cookies to work, or at least URL mangling, as you saw. And the off-host storage can be inefficient. You can fix that somewhat with some of the with the property in the page class that we looked at, but you still have the round trips on all pages that use it. Then we took a look at cookie state. You can use cookies. This is also per client, and it's always round-tripped back and forth to the client. So the client's going to send the cookie value back with each request that he or she makes to you up until the cookie times out. And some limitations here. It's limited in size to about 4 kilobytes. It has to be a string. Clients could disable cookies, in which case you might want to have some fallback. And keep in mind the state is round-tripped across the wire. So if someone's looking on the wire, they can see the value of the cookie, and it also increases the size of each request if you put a lot of data there. Profile is an interesting one. It's sort of an alternative to session, and a lot of people prefer it over session. It is persistent by default, which is a nice feature. Always written to a database. It's another per client scope. It's type safe, and it's read on use, lazy read, and write on change only, which is more efficient than the default of session. And it works in a web farm just by pointing your profile data store to a SQL Server database elsewhere on the network. It is, however, a little bit less efficient than in-memory because it's going to go to the database every time it needs data. And the one other drawback to this model is the database schema is predefined. So if you want to use Profile, you're pretty much tied to the database schema that you saw. Even if you build your own provider, Profile really sort of assumes that you're going to be able to write chunks of data out at a time, and it's not, you wouldn't have one column per property very easily. All right, cross-page posting. We looked at the new feature, or the newer feature in ASP.NET 2.0. The ability to cross-page post between two pages by setting the cross-page post URL on a postback element. And it works regardless of any server configuration between pages. Doesn't matter if you're in a web farm. It's per client, but it's only between two pages. Keep that in mind. Also keep in mind the reevaluation of the previous page if you reference that previous page property. And it does create a rather tight coupling between two pages if you use this approach. And we looked at the items collection. This is a collection of data that's around for the duration of a single request. So it's in the context object, and it's available within the scope of one request. But I showed you a couple of interesting examples of it. One is to combine it with server.transfer, so you actually keep everything on the server. And another one is to add a handler in your application class for, say, begin request or add a module. And then you can put information into the items data store and retrieve it on any page in your site just by reaching up into the items collection. So another useful repository. So all of these have their place with a possible exception of application state. In most applications, you'll find that you end up using a good percentage of these depending on what type of data you're trying to persist and what scope you're trying to persist it at. Hi, this is Fritz Onion with Pluralsight, and I'm going to be talking about state management in ASP.NET in this module. State management for web applications is a pretty large topic, primarily because we're building applications on top of a stateless protocol, HTTP, so we need to reach into our bucket of tricks and find other ways of retaining state besides just populating a block of memory in the working process. So there are many ways of storing state in web applications, and we're going to look at all of them. We're going to start off with a brief discussion of application state. This is a global state repository you can put information into if you want to, but I'm going to try to steer you away from using application state very often, and I'll talk about why. We'll take a look at session state, and it turns out there are quite a few features that enhance session state in ASP.NET, and we'll talk about all of those features. We'll look at cookie state. So cookie is just a piece of text that you associate with a particular user, and it will be round-tripped with each request sent back to your server. So it's a convenient way to store small pieces of data on behalf of individual clients. We'll also look at query strings. This is a very straightforward way of appending additional information to your URIs, and is very common to use in web application construction. We'll take a look at the items collection, which is an ASP.NET specific feature for storing state in the context of a single request. And that might not sound particularly useful, but it turns out when you combine the items collection with using server.transfer to navigate between pages, you can use that as a way to transition state from one page to another. We'll also take a look at view state, just a brief reminder that view state is there, and you can use that as a generic state repository as well across posts back to the same page. And then we'll look at some of the newer features of state management, one of which is Profile. This is a database-backed per-user client store that's very convenient to use, strongly typed, and we'll talk about how that works and how to set it up. We'll also take a look at the reintroduction of cross-page posting in ASP.NET that was added in version 2. And they give you a way of sending data from one page to another using a standard post request by setting the action on the form, a very traditional way of sending data between pages. But in the earlier versions of ASP.NET, it wasn't really feasible. And finally, we'll talk briefly about a couple of controls in ASP.NET that you can use to retain state across post back to the same page and sort of change the look and feel based on an index into a view or a wizard control.